Hello, my name is Beth Dixon and I work here in the math lab. It is my job to provide tutoring to students and to provide them the help that they need to be a success in their math class. One way we do that is to provide these videos so that they can get some assistance in their math courses. Now, these videos are not designed to replace their classroom lecture. The most important key to success in your math class is your classroom attendance and participation in class. And these videos are not designed to replace that classroom lecture and that classroom attendance, but they are designed to provide some additional perspective and some additional help, and I hope they do provide both. If you need additional help, remember it can always be found by coming by and seeing us in person in the Math and Behavioral Social Science building in room 222, and tutoring is available. I hope to see you there. Again, my name is Beth Dixon, and I hope you enjoy the video.
Hello, this is Beth Dixon, and let's solve this system of equations. First of all, let's look at our system. X minus y equals 3, and 3x plus 4y equals 16. Notice that we have this system in two variables, x minus y, x and y, 3x and 4y, again two variables. In a system of equations in two variables, we have three basic techniques: graphing, substitution, and elimination. If you're in finite math, you also have some techniques involving matrices. But we're going to stick to the three basic techniques, and of those, on this system, we're going to choose graphing. Now, why would I choose graphing? Graphing is the basic first technique and really illustrates what's going on with a system of equations in two variables. Graphing is our easiest way if the systems solve easily for y, if the equations solve easily for y. And in this case, they do. Now, as an experienced math person, I can look at them and say that. But if you're not so experienced in solving, you may not recognize whether they solve easily for y. So you may want to use another technique when you're such as elimination, especially if the x's are above the x's and the y's are above the y's. But I wanted to also show you how to solve for y. So I chose to do graphing on this one so that I could also kind of review on how to solve for y. On solving for y, remember the first step is to move the x term to the other side of the equals. And when we do that, remember that it changes signs. If you need more additional help on solving these equations, be sure that you either stop by the lab or to check to see if there are other videos on this technique. Once we've done that, remember the x then becomes a negative x on the other side of the equation. Then there's an understood 1 there, so we're going to divide everything through by a negative 1. A negative divided by a negative is a positive. A negative 1 divided by a negative 1 is a positive. A positive divided by a negative is a negative, and that leaves us 3. And yes, that one is easily solved for y. Then I have this equation here, and I'm going to also solve it. I'm going to bring down the 4y. The 3x needs to move to the other side of the equals, becomes a negative 3x plus 16. Bring down a division by 4 because we want the y by itself. And again, notice the 16 is going to end up being divided by 4, which gives us a nice number and makes it very easy to divide and solve for y. Since both of my y-intercepts, the formulas or both equations are in the format of y equals mx plus b, where b is my y-intercept, and both intercepts are whole numbers, that makes it easy to graph. Okay, now let's look at the graph. And I'm just bringing in some graph paper. And the first thing I want to do, and that's to keep from having to go back and forth, is just copy down my two equations. And I'm going to graph this first equation here. Its y-intercept is -3. So I'm going to go down 1, 2, 3 units on the y-axis. And there are videos for graphing, so if you need some additional help with graphing, you can watch those videos as well. Remember that the understood slope on this one is 1/1, and that slope is rise over run. So we're going to rise 1, run 1, rise 1, run 1. And I like to do that till I've kind of run out of room on my graph. Then I'm going to take a straight edge, line up my points, and draw my line. For emphasis here, I'm going to grab another color and graph my second line. It has a y-intercept of 4. So I'm going to go up 4. Then I'm going to count my slope. Again, this case, my slope is -3/4, and that's rise over run. So that means I'm going to go down 3 units over 4, down 3 units over 4, and I've run out of room on the graph. So I'm going to connect these 3 points and draw my line. And notice that they intersect. This intersection is my answer. And where is this intersection? I count it from the origin because it's an ordered pair, and it'll be over 1, 2, 3, 4 units up 1. So it's the ordered pair 4, 1. And that would be my solution. So if I'm looking for the solution, I'm going to come back over here, and so my solution would be 4, 1. X equals 4, y equals 1. And I can check that into the original equations. 4 minus 1, and I don't even need a calculator to check that. I know that 4 minus 1 is 3, and I can check it here as well. 3 times 4, and I'm just putting, in place of the x, I'm putting the 4, plus 4 times 1 equals 16. And again, I don't even need a calculator to do this arithmetic. There's no negatives or anything. I've got 3 4s are 12. 4 times 1 is 4. And 12 plus 4 is 16. And so I've even checked it and know that it's right by checking it out by hand. And notice that this is really just putting together a lot of steps that you already knew how to do, which include solving equations for y and graphing equations. And when you graph the two equations together, then all you do is notice where they cross, the intersection. And that's the one point that makes both equations true at the same time. I hope this video was helpful. If you need additional help, be sure to come by the Math and Behavioral Social Science building in room 222. Thank you.